All right. I would like to give you the answers to the review packet. So you should have out the review packet, your notebook, your reference table, your pen or pencil, and a calculator. So let's get those items out. I'm only going to review with you for 40 minutes. Anything else you want to review would be after school. Okay, let me give you the answers to these questions. Here we go. Number 1 is 4. Number 2 is 1. Number 3 is 1. Number 4 is 1. 5 is 1. 6 is 3. 7 is 1. 8 is 3. 9 is 1. 10 is 3. 11 is 1. 12 is 1. 13 is 4. 14 is 4. 15 is 2. 16 is 1. 17 is 4. 18 is 3. 19 is 4. 20 is 2. 21 is 4. 22 is 3. 23 is 1. 24 is 2. 25 is 2. 26 is 2. 27 is 1. 28 is 4. 29 is 2. 30 is 3. 31 is 1. 32 is 2. 33 is 2. 34 is 2. 35 is 4. 36 is 2. 37 is 1. 38 is 4. 39 is 1. 40 is 2. 41 is 3. 42 is 3. 43 is 1. 44 is 2. 45 is 2. 46 is 3. 47 is 3. 48 is 2. 49 is 3. 50 is 3. 51 is 3. 52 is 2. 53 is 4. 54 is 3. 55 is 4. 56 is 1. 57 is 4. 58 is 3. 59 is 4. 60 is 4. 61 is 2. 62 is 2. 63 is 4. 64 is 2. 65 is 4. 66 is 3. 67 is 3. 68 is 1. 69 is 2. And the last question, 70, is 2. Now, the way I want to go through this is not the way I go through the other reviews. We're going to go page by page. That way we're not flipping around back and forth, back and forth, back and forth. So let's start with the first page. Are there any questions, 1, 2, or 3 on the first page that you would like me to go over with you?
What was the answer for number 3?
I don't know because Lila has my key. 3 was 1.
Are you going to go over the first one?
I will go over whichever questions you ask me to go over. Number 1, okay. I'm asking you for average velocity traveling 30 kilometers west in half an hour. Okay, I want a velocity. Velocities are vectors, which means it must include a direction. 1 and 2 do not have a direction attached, so those are out. To find an average velocity, you need a displacement, which is 30 kilometers to the west, and a time of 0.50 hour. We're looking for that average velocity. So we take the displacement and we divide it by the time. That is 30 kilometers to the west divided by 0.50 hour, which gives you an answer of 60 kilometers per hour to the west. Choice 4. Anything else you would like to go over? Yes.
So use the V1 equals V1 plus VF divided to when there's 2 times.
When there are 2 velocities. Basically, I'm asking you for the average of 2 data points. So you have data points which are velocities, and you want the average of those 2 data points. So you add them up and divide by 2 when you have those 2 data points. Anything else? Okay, next 2 pages gets us through question 11. Anything through 11 that you want to go over? Number 8, you got it, Nate. Okay, number 8 has some data on the bottom of the second page that we have to read. So we have a basketball practice taking place. A player in the drill is running out the length of the 30-meter court, and they're also going back, and they're doing that 3 times in 60 seconds, as we show you here. So they're going out and back, out and back, out and back. I want to know the average speed. All right, so if I were to list my givens, I want this average speed. I need to know the distance they've traveled and the time over which they've done that. In one drill, out and back, they're going to go 30 meters out, 30 meters back, which means in one set, they're doing 60 meters, 30 plus 30. They're going to do that 3 times. So that distance is 180 meters, right? 60 times 3. We are told they're doing that in 60 seconds. So to get the average speed, we take the distance traveled and divide by the time. 180 meters over 60 seconds gives you 3 meters per second, choice 3. Anything else through question 11 that you'd like to go over? All right, then the next 2 pages, please, through question 20. Anything here through question 20? All right, you have a question? I'm sorry, no? Okay. Yes, number 15. Now, this one would not show up tomorrow, but it is a question that came from Unit 4. So let's talk about it because it's still accelerated motion. So you have a rock that is falling freely from rest on a planet where the acceleration due to gravity is 4.0 meters per second per second. What is the speed after it has fallen 32 meters? So for my givens, I would have a VI of 0 meters per second. That comes from rest. The acceleration is 4.0 meter per second or meter per second squared. And the distance fallen is 32 meters. I'm asking you for the speed once it's fallen that far, which would be the final velocity. Based on the equations on page 6 of your reference table, you should have selected VF squared is VI squared plus 2AD. Since the VI is 0, the equation for VF becomes the square root of 2AD. So we're going to do the square root of 2 times 4.0 meter per second squared times 32 meters. So we work that out on the calculator. So that's the square root of 2 times 4 times 32. And that gives you a final speed of 16 meters per second, choice number 2. Anything else through question 20? Eric? 13, you said? Yep. 13 deals with some vector math where we ask you for the resultant. We talked about resultant displacements. We can also do it with velocities when I'm giving you 2 velocities as arrows. The resultant is the vector sum of those things, meaning that if the boat went this way at 2.0 meters per second, but the river pushes them downstream at a rate of 1.5 meters per second, the boat actually ends up moving like that, head to tail. Remember we talked about adding vectors head to tail? That is the resulting velocity that we're looking for. Since these 2 directions are perpendicular, we can find that by using Pythag. Now, I actually don't have to do the calculation because I know that 1 is not pointing in that direction, nor is 3. Process of elimination. Those are out. I also know 2 is out because I know in a triangle that the hypotenuse is always the longest side. It is never the same length as either leg. So which one does it have to be? It's got to be 4. This one makes no sense. You can't have the hypotenuse the same length as one of the legs. But you should be able to get this answer using a squared plus b squared equals c squared. Okay. Anything else through 20? Jackson? 16. 16 shows you a graph between speed and time for something falling freely from rest near the surface of the planet. I want to know the total distance traveled. So I could give you a graph like this and just tell you it wasn't falling freely from rest. This is an object that's accelerating over a 4-second time interval. I want the distance. I'm going to do this using my guess method. From the graph, I can see that my initial speed is 0 meters per second. I can see that the final speed read from the graph, it's not exactly 10, but let's go with a final speed of 10 meters per second, approximately. Okay, that would be at 4 seconds here. Pass. Thank you. So I'm giving you a time of 3.0 seconds. I'm looking for the distance traveled. I don't have acceleration. I do have an equation on my reference table, which tells me that my average speed is equal to distance over time. So the distance traveled would be the average speed times the time. Now I'm going to come back to a question that Nikki asked me a little while ago about an average. I have 2 data points for speed. How do I get the average of those data points? How do you get an average of 2 data points? Add them and divide by 2. Just like if you had 2 test grades. I would add them up and divide by 2. So what's the average of 0 and 10? 5. So I'm going to take 5 meters per second, multiply by the time of, hold on a minute. My mistake. 3 seconds. The final speed is not 10. It's at 3 seconds, it is 8. My mistake. So the average is not 5, it is 4. There we go. All right. So 4 times 3 would give me 12 meters, choice number 1. Okay? Anything else through 20? Colin? That's the same exact thing. Because what you were doing is 1/2 of 3 times the height of 8. Mathematically, it's the exact same thing, right? Because half of 8 is 4 times the 3. Yeah? 18. So let's use our guess method. We have from rest, 50 meters per second, 5.0 seconds. What's the average speed? So we know our VI is 0 meters per second. The VF is 50 meters per second. And the T is 5.0 seconds. I want V bar. The time is irrelevant. I have the two data points for speed. How do I get the average? Right. What's the average of 0 and 50? 25. Anything else through 20? Josiah, do you need the answer key to check yours? Yep. You're welcome. Nothing else through 20? All right. How about the next two pages then? How about through question 28? See, Chang? 23, yes. So we have a car that goes 90 meters north in 15 seconds. They then turn around and go 40 meters south in 5.0 seconds. What's the average velocity in that 20 seconds? Okay. So the first thing I have to do is recognize that I want this average velocity, that based on the values, I'm going to need the displacement and the time. The time is 20 seconds. That's how much total time. To get the displacement, I'm going to make a sketch. We're going 90 meters to the north, and then we have to turn around and come back 40 meters to the south. The displacement is that arrow right there. What is the displacement? It's 50 meters to the north. To get the average velocity, I'm going to take that displacement and divide by the time. That is 50 meters to the north over 20 seconds. So that gives me an average velocity of 2.5 meters per second to the north. So its magnitude is just 2.5 meters per second, choice 1. Anything else through 28? Hudson. Sure. 22 says, we have a motorboat with a speed of 5.0 meters per second in still water going to the east. It's crossing a river which goes south at 3.3 meters per second. What is the resulting velocity? This is a lot like that other question where I drew the arrows, except I didn't give you the arrows here. Notice I'm going to go east at 5.0 meters per second, but the river is pushing it south at 3.3 meters per second. The resultant is the hypotenuse of that triangle. What is that velocity right there? Do you know how to get it now? What do? It's a right triangle. So how do you find the hypotenuse? Yeah, use Pythag. Okay, so let's do that. 5 squared plus 3.3 squared, take the square root, and that's going to give you 6 meters per second, choice 3. As soon as you start to see directions, things as vectors, you should really be sketching it out, making a picture. Anything else through 28? Yes, Jackson? 24. All right, 24 says that we're going 12 meters in 4.0 seconds as we accelerate from rest. What is the acceleration? So my givens would be a VI of 0 meters per second, a D of 12 meters, a time of 4.0 seconds. I'm looking for A. The only equation on your reference table, which has those 4 letters, Jackson, is D is VIT plus 1/2 AT squared. The VI is 0, so that's going to go away. So we have to manipulate this equation and solve it for A. That equation for A becomes 2D over T squared. That is 2 times 12 meters over 4.0 seconds, which must get squared. So that's 24 over 16. 24 divided by 16 is 1.5 meter per second squared, choice 2. Anything else through 28? All right, next 2 pages through 36. Anything through 36? See Chang? 36, yes, 36. We have a 16 meter per second, a 20 meters per second, 36 meters, I'm looking for acceleration. So the VI is 16 meters per second. The VF is 20 meters per second. The D is 36 meters. I am looking for A. The equation on your reference table, which has those four letters, is VF squared is VI squared plus 2AD, which means the manipulated equation for A is VF squared minus VI squared over 2D. So that means I'm going to take 20 meters per second, square that amount, subtract the square of 16 meters per second, and then divide by 2 times 36 meters. So now you're going to go to your calculator. 20 squared minus 16 squared. That gives me 144 in the numerator. The denominator is 72. 144 divided by 72 is 2. So 2.0 meter per second squared, choice 2. Anything else through 36? Is it necessary or can you wait? I would prefer that you wait. That way you are here for the review 100%. Anything else through 36? Mia?
35.
Yes, 35 is again asking you for a resultant velocity. Now we've done 2 of them where I asked you for resultants. But the issue is that the 2 velocities I'm showing you are not drawn head to tail. They are not drawn head to tail. They're drawn tail to tail. So I'm going to move them so they are head to tail. 1.50 meters per second to the east and 0.70 meters per second to the north, which means that the resultant is that arrow pointing up and right. These are perpendicular. So how would I get that value, Mia? Yeah, do Pythag with those 2 numbers. 1.50 squared plus 0.70 squared. Take your square root, and that's going to give you an answer of 1.7 meters per second, choice 4. You will see them drawn like this a lot. You have to know to move them like this because the resultant is not that. If you draw that, that is wrong. You lose all credit. You have to know to move them head to tail. Otherwise, you can't find the direction. And it makes no sense. If something is traveling east and north, it's headed northeasterly, not northwesterly or southeasterly. All right, so you got to make sure you put them in a head to tail type of fashion to come up with that. Anything else through 36? All right, next 2 pages through 49. Anything through 49? Dan? 43. Okay. We're dropping something from a 3rd story window. I want to know how far is it falling? Oh, 43. Okay, good. Look. Yes, the one above that. Thank you. So we have a rocket at rest. Here's an acceleration. There's a distance. I want to know how long it takes. So my VI is 0 meters per second. I have an acceleration of 2.0 times 10 to the 1 meter per second squared and a distance of 9.0 times 10 to the 3 meters. I'm looking for T. The only equation on our reference table which has those 4 values is D is VIT plus 1/2 AT squared. Since VI is 0, that's going to go away, which means I'm going to manipulate D is half AT squared for the T. So the T will be the square root of 2D over A. That is the square root of 2 times 9.0 times 10 to the 3 meters over 2.0 times 10 to the 1 meter per second squared. So when I work this out, you can put your calculator in scientific notation. Since they're all in scientific notation, go to the Sci mode and work it out. So the square root of 2 times 9E3 divided by 2E1 gives me an answer of 3 times 10 to the 1, which is choice number 1. Anything else through 49? All right, next 2 pages then through question 60. Anything through 60 that you would like to ask? No? All right, then. How about the next 2 pages, the last 2 pages through question 70? Anything you want to go over here through 70? If you guessed, that's not good. You don't want to be guessing correctly. You want to know how to get the answer. No? We're done? Okay. So for tomorrow's test, please make sure you bring a pen, a pencil, a ruler, a protractor, and a calculator. Okay? That's what you'll need. You'll need all that stuff. The best kinds of questions. Obviously, you're going to have 10 multiple choice. Most of them are right out of this packet. But then the rest of it, to figure out what the show work questions are going to look like, you should go back and look at your Unit 1 test, your Unit 2 test, and your Unit 3 test. Look at all those show work questions. That's pretty much what your test tomorrow is going to look like. Any of those kinds of things. The ruler, protractor, head to tail drawings to scale, measuring things out, converting it with the scale diagram, measuring angles, all that kind of stuff will be on tomorrow's test, along with graphs. Can you draw a graph correctly? Can you set it up? Can you tell me the shapes of the graphs, the relationships on the graphs, the guess method stuff? It's all there tomorrow. All of it for all 3 units. Okay. Nothing? All right. So the rest of your time now is to finish working on test corrections if you have any. And that's where we're going to end. We do have about 15 minutes before the class period ends. So you can either work on your Unit 3 test corrections, or you can work on something for another class, but it is not social time. Not social time, okay?